Okay, today we're learning about 9-6. It is still working with the trig functions. We're still working with sine, cosine, and tangent, but we're going to be working with the inverse of sine, cosine, and tangent, and we're going to be solving right triangles. Okay, before we start to do this, you've got to go and set on your calculator at this screen. You've got to go over here and go to number 5 where it says settings. You're going to go ahead and push number 5 from this screen to go to settings. And then when it goes to this screen for settings, we're going to go do number 2 for document settings. When you go to the document settings, it'll look like this. You've got to go down to the angle. You need to make sure that the angle is in degrees, not radians. Then you can come over here and get it to make default, and it will set it into degrees. So you have to have it in degrees in order to do these trig functions, or you'll get all your answers wrong. Okay, so let's go practice the first one. It wants us to determine which of the two acute angles has a cosine of 0.5. And we know cosine is going to be adjacent over hypotenuse for cosine. So if we go and do angle A first, angle A, just labeling it, this would be our hypotenuse. And then this is our opposite to that angle, which makes this over here the adjacent. So doing for angle A, cosine of angle A would be square root of 3 over 2. And when you go in and do that in your calculator, you should get 0.866, so 0.87. That doesn't give us our 0.5 that we're looking for. So let's go and try it now for angle B, still using cosine, which is adjacent over our hypotenuse, but now we're going to do it for angle B. This is still our hypotenuse, the one directly across from the angle's opposite, which would make this one over here adjacent. So if we do the cosine of B, that's going to be 1 over 2, and when we put that in our calculator, we should get the 0.5. So our answer to this one would be angle B. Angle B will give us the cosine to be 0.5. Okay, this is where we go and find the angle measurements. We're going to use the inverse. So when you go and push your trig functions, you need to make sure that it says tan negative 1. That would be the inverse to find our angle. That is still going to be using opposite over adjacent. Sine is still going to be using opposite over hypotenuse, and cosine is still going to be using adjacent over hypotenuse, but we're going to be using the inverse of it. So you have to make sure that when you're finding the angle, it would say have the negative 1 with it. Let's go and just put these in our calculator to see what we get. So to put this one in our calculator, the tan of A, all we're going to do is on our calculator, you're going to go and push your trig functions. But you need to go ahead, since we're finding the angle measurement, you need to go ahead and put tan and make sure it has the negative 1 in there before you go and push in 0.75 in the parentheses. And it would give us the angle measurement of 36.9. Okay, for sine of angle B, same thing. But when we go and push this in our calculator, it has to have the sign of negative 1, and we put the 0.87 in our calculator. And for this one, it should give us 60.5 for our angle measure. Okay, then for the cosine of C, make sure that when you put it in there, you've got the negative 1, cosine of negative 1 for the inverse, and put the 0.15 in there, and you should get 81.4 degrees. Okay, here's for you to try these. Next, we're going to be solving for a right triangle. When you solve for a right triangle, basically what all you're doing is you would have the lengths of all three sides, We know that one of our angles is 90 degrees, but you would also end up getting the getting the measurements for both of the angles also. So basically you would have the lengths of all three sides and the measurements for all three of your angles for solving a right triangle. Let's go and practice one. We know that to find the other side of this right triangle, we can always use Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, our longest side and our c will always be directly across from our 90-degree angle. So what we do not know is the c. So I can do 3 squared plus 2 squared would equal our c squared. We know that this is 9 plus 4 would equal our c squared. So we would get 13, but then at the end we have to go through and take the square root of 13. So our c, that other side, would end up being, okay, the other side would get us 3.6. So now we know that this side is 3.6. We can go end up finding the measurements of angle A that we do not have and of angle B, but let's go do angle A first. If we do angle A, we can go ahead and use the tangent. It doesn't matter which one we use, we just got to pick which one we use. I'm going to use tangent because we already have the 2 and the 3. So the tangent of angle A is going to equal opposite, which is 3, over adjacent, which is 2. So if we are solving for the tangent of A, I would go ahead and put it in your calculator. And remember, and I didn't write that up above, but you are using the inverse tangent. So when you go and do that, you're going to use the inverse tangent, and you can do in your calculator 3 divided by 2, and it will end up telling us that the measure of that angle is 56 degrees. So we know that angle A is 56 degrees. This one was 3.6, that's 56. If we have 180 degrees in our triangle, we know one of our angles is 90, the other angle is 56, then we can go ahead and find the measure of the last angle, which would be 34 degrees for angle B. That is how we solve the right triangle. We've got all three sides, and we have the measures of all three angles. Let's go try another one. Okay, we're going to solve this right triangle. Okay, we know that we're finding the measures of all of our angles and all of our sides. If we look at this, we have one angle that is 90 degrees and another angle that is 25 degrees. So we can go ahead and subtract that from our total that is 180 to go ahead and find the measure of that other angle. And the measure of that other angle for angle G would be 65 degrees. So what we need to go do is find the measures of the lengths of G and the lengths of side H. Okay, it doesn't matter which one we use, we just have to decide whether we're going to use the 25 or the 65. I'm going to go ahead and use the 25 over there. And I'm going to use my hypotenuse. So if I'm looking at angle H, I'm using that 25. I'm going to use my sine. I'm going to use the sine of what we're trying to find. This would be that angle G. I'm just going to call it X for all our purposes here. So the sine of X is going to equal, the sine of 25 degrees. Let me go back and fix that. 25 degrees is going to equal our opposite side. We do not have, I have to use, let me start all over on this one. I just so messed this one up. I'm sorry. Let me go over on this one. I am going to use the 25 degrees, but I'm going to use it to be solving it for this one. This is the one I'm calling X. And it is adjacent to our H, and that's where I was messing up. I kept saying sine, and it's adjacent is going to be cosine, because adjacent would be adjacent over hypotenuse is cosine. So we're going to actually do the cosine of 25 degrees is going to be, adjacent is the one we do not know, over our hypotenuse, which is 13. And we're just going to solve this for X like we normally would. So to get rid of our 13 in the denominator, I would have to go and multiply it on both sides. So our answer for So our answer for this one would be, when we put it in our calculator, it would be 11.78. So that would mean side G equals 11.78. Let me go erase this other stuff. Okay, there's only one side that we do not have, and we can go ahead and use our Pythagorean theorem, or we can go ahead and use, still using this 25-degree angle, we could go ahead and use sine this time. Sine, to find this h, is where I'm going to put my x there, where the h is, and I would be doing the sine of 25 degrees is going to equal x over 13, because sine is opposite over hypotenuse. And opposite to our 25-degree angle is going to be where I put my x. And hypotenuse is over here where the 13 is. It doesn't change. So same concept. Go ahead and get rid of the 13 in our denominator. We would multiply both sides by it. So then that's what we would go put in our calculator. And we would get the length of our side over there for h to be 5.49. So we have ended up finding all three angles. We've got all three angles, and now we should have all three sides. This side is 5.49. Side G was the 11.78. Our hypotenuse over here is 13. We've got both of the angles, or all three angles. One's the 90 degree. We've got angle G is 65 degrees and angle H is 25 degrees. So we have solved the right triangle by finding all three sides and all three angles. Now you try. There's actually two problems for you to go try after this.